works. So, problem number what?
6.
Number 6. For those of you watching at home, howdy. We were just going through homework. It says assignment, but it's really 6B-3. We're looking at problem number 6. Y equals 2 secant of x. Y equals 2 secant of x, and then y equals 0. These are the boundaries of the region they're talking about. X equals negative pi over 3, and then x equals pi over 6. First thing we need to do is graph this thing. I'm hesitating whether I should even tell you this. There is a way to do this on the calculator. Tentatively. I'm not sure you'll thank me, but there is a way to do it in case you get, I don't want people to get dependent on the calculator for one thing, and number two, doing it on the calculator might arguably be longer than doing it by hand, depending on how comfortable you are with graphing secant and cosecant. If you can graph secant and cosecant by hand relatively quickly, it's quite a bit faster than the calculator. That being said, take out your calculators, I want to show you something. I'll try and hold this up for the people at home. We're looking at y equals screen. Clear out any formulas you have in the y equals screen. Question, where's the secant key? There isn't one.
Second.
I wish. Second blah 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 gives you an inverse function, not the reciprocal function. The inverse function is quite different. How do you get the reciprocal function? Like, what is secant off the top of your head? Exactly. It's 1 over, in number 6, it'd be 1 over what? Cosine. What about 2 times secant? What would 2 times secant be? 2 over cosine. Right. So 2 divided by cosine of x. Hit enter. In y1. Correct. So 2 divided by cosine of x. That's really the same as 2 secant of x. Now, a couple things you got to be careful about. First, whenever you graph any trig function, whenever you play with any trig function other than like algebra 2, what mode should it be in? Radians. Go to the mode key and make sure it's in radian mode. It should be like the second or third row down. There'll be 2 options, radian and degree. Make sure it's in radians, otherwise you will get the wrong answer. And you'll also get the wrong graph. Everybody good so far? Go ahead and hit quit. And in order for this graph to work, I need a correct zoom setting. This is where things get really interesting. If you want to use it on the calculator, you need to be familiar with the zoom key, and you also need to be familiar with the window key. Again, at this point, if you can sketch this by hand, it might be faster. I'll show you how to do it on the calculator because I promised you I would, but I need to set up zoom settings that would have this entire graph on screen. That's not always trivial. Just for fun, go to Zoom and select Zoom Standard, which is Zoom 6. Hark. Hi.
I thought it was a man. You guys were like, I thought you were a man. So I'm going upstairs.
And I'll check off your worksheets in a bit. We're going through problem number 6 on the assignment.
I got your lunch. Oh, you're so separated.
While you're at it, grab your calculators.
You are here.
We have just graphed the following. For the people who just came in.
Oh my God.
Whoops.
And we thought for you. We thought you weren't here.
Y equals 2 divided by cosine of x. Put that in the y equals screen under y1. Okay. This is really 2 secant of x. In other words, we're trying to graph this on a graphing calculator. And I did warn people, this is not necessarily faster than doing it by hand. Okay? First of all, any questions for the people who just came in? Or for anybody who was already here? Okay, for people who are watching at home, is there anybody still watching at home?
Well, Michael.
Oh, Michael, that's right. Okay, so Michael, what we did, we tried to graph this, and we did zoom
Oh, 'cause that's what.
standard.
Or sorry, see.
It's the zoom key 6. And it looks like, could somebody look on the video screen and see if this is on screen? Okay, good. This is what I get when I hit zoom standard. That's not the most useful graph in the world, for 2 reasons. I want to know what the boundaries are from -pi/3 to pi/6. I also want to make sure that I capture the entire graph. So, hit the window key. The window key, can we find it? Where is it?
Between y equals and zoom.
Between y equals and zoom. Go ahead and do that. You've got a whole bunch of settings. What you should see is the title window, and then you should have xmin, xmax, xscl, which just ignore. But the min and the max are what we're going to play with. If you're going to the window key, xmin and xmax are the boundaries of the window. You can change your zoom setting to whatever you want. This is customizing it. So x minimum, it should be at -10, because we just did zoom standard. Zoom standard goes from -10 to 10 in x, and -10 to 10 in y, but you can change that to whatever you want. What I want to change it to, the x min is -pi/3. So type that in. Over x min, like use the arrow key to get up to x min if you're not already there. And do negative, then you need the pi key, which is second caret. That little power key.
Wait,
And then divide
this is an X-Men?
in x min, correct. Yeah, x min is going to be the left-hand side of the screen. So remember that when you're graphing, x is left, right? The x minimum is how far it goes to the left, the smallest x that the screen will contain. Anybody guess what x max is? 5 or 6. So scoot down with the arrow key. By the way, when you scoot down, you might notice that x min is converted to a decimal. It should say -1.047 something. That is -pi/3. It just doesn't know how to do non-decimals. Now type in for x max pi/6. And that should convert to like 0.523 something. Everybody have that? Now hit zoom. Or, not zoom. Now hit graph. Let me see what your graph looks like. Hold up calculators. Yes. Yeah, that's looking good. Let me see what it looks like. Yes. Correct. Yes. And by the way, people at home should look like that. I hope it's on screen.
Yep.
Okay. So it looks like a relatively boring looking graph that swoops just a little bit. Here's what's all on the screen. Kind of like that. And that's all you should see. This is the graph of 2 secant. This boundary is -pi/3. This boundary is pi/6. Okay? Questions so far? That was a bit of tweaking and fudging that does take some time. If you're in the middle of a test, I will suggest that if you can sketch this by hand, it will be faster. And remember, the whole point of sketching this is not to find any specific points. It's to find out which way the radius goes. So this, let's step through. Everybody look up here? Everybody? This is one of the boundaries of the region they're talking about. Y = 0 is another boundary of the region. That's the x-axis. then this line of x equals negative pi over 3, and this line of x equals pi over 6. This region is what they're talking about. Okay? Does that make sense? Look at the instructions for problem number 6. Which axis are we spinning this thing around? X-axis. So it's around this. Does everybody see sort of visually what you're going to get? You're going to get a mirror image here. And it's going to spin like this. It's going to make kind of like a vase-shaped thing. Which way is the radius pointing for all the disks? In the x direction or the y direction? The y direction. If you take any given slice, it can look like that. The radius is going in the y direction. That's pretty much all we needed. What about the height, the thickness of that thing? Is it in the x direction or y? X. What would you call it?
dx.
Dx, because it's thin. Dx or dy if it's very, very thin. So the radius is y, and dx is the height of the cylinder or the thickness. So can somebody tell me the volume of a disk? Do this again. Pi r squared h, because that's the cylinder volume formula. So pi times something squared times something. Polly, take over. What would I put here? Y, correct. And what would I put here?
dx.
Exactly. Anybody see anything wrong with that? Gentlemen,
Different terms.
I am talking to you. They're different, yeah, they're different variables. What do you want to fix?
We can fix the y probably because you can put in 2 secant x
Yep.
squared.
So you can have x parentheses squared dx. That at least looks better. Now, if you're trying to get an integral, because this is the volume of one disk, I just gave it away. How do you get the whole volume? Take an integral. From what to what? Max. From what to?
Pi over 3, pi over 6.
From negative pi over 3 to pi over 6. Correct. Of, can somebody expand that out for me? Like, what's 2 secant times 2 secant?
3 secant squared x.
Close.
Or
4 secant squared. So it's going to be 4 pi secant squared of x dx. Everybody see where they came from? The pi was already in there, and 2x times 2 secant times 2 secant is 4 secant squared. One last thing before we actually take the antiderivative. Jack, what would we do?
Pull out the 4.
Actually, you can also pull out the pi, correct. So I'm going to pull out the 4 and the pi, and just take the antiderivative of secant squared. Okay, math people. What's the antiderivative of secant squared? Anybody?
Tangent.
What's that? I heard it.
Tangent.
Tangent, correct. So keep the 4 pi outside. This is going to be tangent of x. Evaluated from negative pi over 3 to pi over 6. This, do not do in a calculator. The calculator you can use for the sketch of the graph if you want. Frankly, I think it would be faster if you just got familiar with these and did it by hand, but I'll leave it up to you. But this, if you do this on a calculator, you will get a decimal answer, and I will mark it wrong, which is bad. So, somebody tell me how to take this antiderivative? Like, Jenna, go for it. How do I,
So
what
you
do I
just
put
do-
first?
You just do 4 pi tangent of pi over 6
Yes.
minus tangent of negative pi over 3.
Yeah. Tangent of pi over 6 minus tangent of negative pi over 3. Everyone in here should be able to find the exact values of those two. Pete, what is pi over 6 in degrees? 30 degrees. What's the tangent of 30 degrees?
Tangent of 30 degrees is the radical 3 over 3.
You got it. Radical 3 over 3. If you get stuck, feel free to draw a unit circle. I always do when I do my answer key. Pi over 6 is the 30-degree position. And the slope of that is radical 3 over 3, positive. Negative pi over 3 is here. It's negative 60 degrees. By the way, that has the exact same slope as what other angle? This is negative 60. I mean, it also has 300, but that's the same spot. Can you name one other place on the unit circle where it has the exact same slope? 210 is here.
Oh, negative
I'm gonna do
60. Oh, sorry. 120.
120, correct. What slope is it? First of all, Julie Miller, the slope for this thing, positive or negative?
Negative.
Definitely negative, it's downhill. Does it look like it's big negative or small negative?
Oh, small negative.
Well, for example, look at the positive ones. Which one has a bigger slope?
Because it's
What's that?
big negative.
Yeah, it's a bigger looking negative. So what slope is that, opening up to anybody?
Right.
Radical 3, very good. And if it's going downward, it's gonna be
Negative.
negative radical 3. So minus negative radical 3. So we see what I did? The answer to this minus the answer to this. Still with me? These, you just have to dig up from last year. What's minus a negative? Anyway? Yeah, plus. So how do you add these things? Yeah,
Common denominator.
common denominator. Like what?
3.
3. So multiply top and bottom by 3. So it's 3 over 3, radical 3 over 3 plus 3 radical 3 over 3. What do I give you?
4 radical 3 over 3.
Yeah. So it's 4 pi times 4 radical 3 over 3. Give me the final answer.
So it's 16 pi radical 3 over 3.
You got it. That's where they got that answer from. Does that make sense? Any other ones you want to dissect?
I just have a question.
Yeah.
For all
Sorry, wait.
problems you give us
Uh-huh.
that are similar to 5 and 6, we always use common angles.
Well, yes.
Okay.
Yes, I will. By the way, if I don't use common angles, then you are free to use a calculator and get a decimal approximation. Pretty much from last year, the only trig values you were on to get exactly were common angles. Non-common angles, just use your calculator. Question?
So is there a 1 in front of the 3, radical 3 over 3? How did you get the 4?
Oh, there is a 1 in front of this.
Okay.
Correct.
And then radical 3 plus radical 3 equals radical 3?
Well, 1 radical 3 plus 3 radical 3 is 4 radical 3. It's kind of like 1x plus 3x is 4x.
Okay, so you don't have to add the radical 3?
Correct. And radicals don't add as it is.
Oh.
Like radical 2 plus radical 3 would not be radical 5.
Got
It works for multiplying though. Radical 2 times radical 3 is radical 6. But yeah, treat these like variables. It's, well actually I actually stole this from a student in one of my previous schools. They basically said radical 3 is sort of unknown because nobody has the entire infinite decimal. So if it's unknown, treat it like an x. So it's like 1x plus 3x, it's 4x. And then if they're two different radicals, treat them like two different variables. It's like, I'm just gonna make this up. 2 radical 3 plus 3 radical 5. It's a little like 2x plus 3y. They're not like terms, so you're just stuck. And just leave it. Okay. Any other questions you wanna have on these? Yeah,
Number
4.
4.
Okay. Find the volume of the solid. X equals negative y squared plus 4. This could make people scratch their heads. Ironically enough, we're actually studying this in pre-calc right now. This is a sideways parabola. But let's pretend you don't remember that. X equals negative y squared plus 4, I think it was. Yeah. And then x equals 0, y equals 0. And then y equals 2. So how do you find the area? They want to spin this around the y-axis. So about the y-axis. Do you remember the trick I showed you? This thing is a bit annoying to graph. It's a sideways parabola. I mean, it's not horrible, horrible.
Can we use our calculator?
It's going to have an x-intercept of 4. Ironically enough, yes and no. The calculator does not know how to graph x equals.
Oh,
It only knows how to graph y equals.
so can you
So if
teach
you-
them?
Can you get y by its, what was that? Yes and no. Here's the graph.
If you get y by yourself.
Yeah. Can you get y by itself? Yes. You would not thank me. If you get y by itself, you'd have y equals plus or minus the square root of something. If you get y by itself, you would regret it. You would have two different functions. You'd have plus or minus the square root or whatever. Quick question. On your calculator, where's the plus minus key?
On the side.
Plus minus key. It's a trick question.
There isn't.
There isn't one.
There's not?
Nope. There is, when you're doing a square root, those are separate, plus and then minus. But like plus minus, I like for in front of a square root.
You can just. Yeah, you can just press them on.
Oh, plus minus, got
Like that.
it. Okay.
Yeah, no, you have addition and subtraction. But there is no plus minus key. How would you graph a square root? Not a radical, but a square root on that calculator. Because the calculator has a plus minus in front. Amen? Yeah.
Do two functions.
You have to do them separately. You have to do y1 as the positive and y2 as the negative. And that would be really, really a pain. And it would probably take you a half hour and you'd probably get the wrong answer. Does anyone remember the sneaky trick we did here? Yeah. You can take the inverses of all these. By the way, just so people know what this is like, this is x equals 0, y equals 0, and y equals 2. So basically they're talking about this thingy spun around the y-axis. Everybody look up here. Everybody. Here, just take it on faith. This is what the graph looks like. Do you see this sort of, I don't know what shape that is, but if you rotated it around the y-axis, it would give you this sort of half skittle, I guess. This sort of dome thing. And you have to find the volume of that. What would happen if you took the inverse of everything? In other words, every single x replaced with y, every single y replaced with x. Go ahead and do it. Julie Miller, what would this look like if you inverted? Like just swap the x's and y's.
Like, okay, y
Uh-huh.
equals negative x squared plus 4?
Yep. Keep going.
Oh, y equals 0.
Y equals 0,
X equals 0.
x equals 0.
X equals 2. Can you just do that though?
Yes.
Okay.
I will warn you, in the physical world, you are doing something really extreme. You're basically taking the universe and flipping it 90 degrees. That's quite dramatic. However, let me show you what the graph is. Does anybody recognize this graph now? Like everybody who's gotten through first year algebra should be able to graph this one. What shape is it? Bravo. Opening up or opening down? Down. And y is the leader, so it's not a goofy sideways parabola. And where's the vertex? What comma what?
Something comma 4.
Something comma 4. It's 0 comma 4, because there's no subtraction here. Normally this would be y equals a parentheses x minus h squared plus k. There's no parentheses, so it's x minus 0. So basically here's the y-intercept. And it's going down, it's normal height, over 1, down 1, over 2, down 4. So here's your, so again, this one should be a lot more comfortable. This one, we pretty much needed pre-calc because we never touched it except maybe second year algebra, I don't know. I doubt it. Now try these. Y equals 0. That's the x-axis. X equals 0, which is the y-axis. X equals 2. In other words, we're looking at this. And by the way, look up here, everybody. We forgot something. It's about the what? You switched everything else, you gotta switch this too. It's about the x-axis. So we're spinning it around here. So we're going to get something like this. We're going to get the exact same half skittle, which will have the exact same volume. All you needed to do from this graph is find out which way the radius is going. Can you tell? Here's the way it's spinning. Yeah.
I have a question. Why does it matter which way we spin it? Because won't it get the same area? Because it's the same like amount being transferred over.
It actually will not. You'll get a very different volume if you spin it this way.
Okay.
Because it's much, much longer this way than this way. You'll actually get a smaller volume if you spin it this way.
Okay.
Yeah, sometimes, like if it's a perfect circle or sphere, then it will be the same.
Okay.
But if it's lopsided, yeah, that's kind of a surprise. If you spin it this way versus this way, sometimes dramatically different volumes.
Okay.
Yeah, good question. So which way does the radius go? X or Y? The Y. Because here's the disk we're going to be doing. So the volume of a disk is pi r squared h. Can somebody fill those in for me? Which way is the radius? Pete.
The radius would be in the y direction.
Correct. So they put y. And how about the thickness?
Thickness is in the x direction.
dx, correct. If you had done it up here in the original one, it would have been pi x squared dy. Because the radius would be in the x direction and the thickness is in the y direction. Does that make sense? But that would have been annoying. Let's do this one. Something wrong here. Let me see what? Oh,
You have to replace the y,
with what?
the negative x squared plus 4.
Exactly. Negative x squared plus 4 squared. Let me rewrite that. I'm about to give you one last gift. Grab your calculator. I would not do this with trig. The reason I would not do this with trig is because it gives you radical answers almost always. This thing, I see no radicals anywhere, and I'm plugging in whole numbers. Chances are the calculator should be able to handle this and give you an exact answer. Let's try it. Go to Math 9. What I'd like you to do is don't type in the pi. Wait on this. Don't type the pi in. Just type in parentheses, like new parentheses. If you have an old calculator, it's FNINT and it gives you a parentheses for free. Use an extra parentheses. Then do negative x squared plus 4, close parentheses, and square. It will know how to do that. But you could expand this out, square the first double product, square the last. It's not that hard. Comma, x, because we're doing dx's. Comma, what? You tell me.
0, 2.
0, 2, correct. Because that's how far the x's go. Close parentheses, hit enter. What do you get?
256 over 15.
Yeah, then we get 17.06666667. Hit convert to fraction. Without the pi, it converts to 256 over 15. We got 256 over 15. What's the final answer though? We forgot something until the end.
256 pi over
Pi.
15.
256 pi over 15. Got it. Make sense? Any other questions? Going once. Twice. twice. Did we catch that trick? If you want to get an exact answer and you want your calculator to help you, leave the pi off, because the pi will destroy your calculator's ability to convert to fraction. There's no way to convert pi to fraction. But if you leave it off temporarily, don't forget to put it back when you're done. Convert the rest of it to fraction, and then plop the pi back in. Make sense? Alrighty. I have heard your pleas. I have heard your heart-moving cries for, please, Mr. Conklin, can you not give homework over the break?
You never get home right over break.
Don't spoil something. Take out your notes.
I mean, oh wow.
I want to show you one last
Oh, merciful Mr. Cochran.
new.
We will worship at your altar.
But I want to show you one last kind of strange
I know, I mean,
thing.
I don't know. I literally don't know. What is this?
Suppose the base of a 3D
18th and
shape.
21st are
Write this down.
illegal and legal alcohol.
The woman's Christian temperate
Is
donate alcohol
That's
and like the prohibition.
what was the formation of the
bounded by y equals radical x, y equals 0, x equals 0, x equals 4. Go ahead and write that down. This section is all about three-dimensional volumes. Well, three-dimensional shapes and finding the volumes. This is the first time we're not going to use rotation. It's going to be a little stranger. It's going to be a little hard to draw. So humor me there. Can somebody graph the bounds we're talking about? I'm just holding the marker. Somebody direct me. Can somebody graph the base of this? In other words, it's kind of like if you have this big blob of clay or something, and you plop it right onto the whiteboard. The base of it, the part that's touching the board, will be in this shape. Can somebody draw the shape for me? Direct me. Shouldn't I anoint someone? Yeah. Y equals radical x. Can somebody help me graph that? We've done that a lot. Yeah, go.
Well, I would start at 0, 0.
0, 0, definitely.
Then I would go to 1, 1.
1, 1,
Then I would go to 4, 2.
definitely. And that's all as far as we need to go. So the graph is going to be a half parabola, the upper half of a parabola going to the right. Then we have y equals 0, which is the bottom, x equals 0, which is this, and then x equals 4, which is this. So the region we're talking about is this. Everybody okay with that? In this entire chapter, you're going to need to be able to graph regions like that. Gentlemen, I need your focus up here. Now, it's kind of hard to picture, but again, let's just say I have this blob of silly putty or clay or something like that, and I go, boom, and I glom it onto the board. And that the bottom of it, the part that's stuck to the board, happens to be in this exact shape. Does that tell you what the rest of the blob looks like? Like, do you know how tall it is? No. Do you know if it's flat on top or curved on top? No, I have no clue. It might be this irregular, lumpy something or other. I'm about to tell you next. Every slice of the base sliced, let me know what that symbol means. Perpendicular. Perpendicular to the x-axis is the base of a 3D square. This is going to be really hard to draw. But picture, if I were to take this slice right here, how long is it, first of all? Don't work too hard. One. Because this is 1, 2, 3, 4, and it goes up 1, 2. So this thing has a length of 1. Picture it's sticking out a square. So this is 1, this is 1, this is 1, and this is 1. Popping out at you. I mean, I had it tilted because, you know, I'd have to cut out a piece of cardboard and actually hold it in order to be actual 3D. But does that kind of make sense? Like if you take a slice here, it's going to be a smaller square. Take a slice here, it's going to be a smaller square. It's a whole bunch of squares that as you go further and further get bigger and bigger.
But they're just like really thin.
Yeah, incredibly thin. Very good point. Remember that. Now, they are going to have a little bit of thickness. My question is, I mean, it's actually kind of hard to picture what this thing looks like. It kind of looks like a croissant with like ridges on either side. There's like a ridge here where all the corners attach, and a ridge here where all the corners attach. So it's like this really sort of, bless you. It's sort of like a croissant where somebody smashed the top and smashed the two sides and made it look kind of square. But it is kind of sort of curving just a little bit. It's very, I used to have a program that could animate, graph this thing, but
Yeah, do like a 3D
the light,
calculator.
that computer crashed and it would cost $400 to get the program again. So I'm not- it's called Mathematica, which is really, really amazing program. Forget it. Question is, what is the volume of a slice? Pete.
Volume of the slices.
First of all, welcome back. Second of all, do you know what the shape of the slice is?
It looks like a rectangle, like a little slight perpendicular, but
Yeah, keep going.
yeah, but perpendicular. Well, okay.
What shape, what basic shape is the slice? Square. This is a square. How do you find out the length of a side? Like, what's the length of a side right here?
Right there,
Uh-huh.
1.
1. Because the height is 1, and then all the other sides are 1. They'll all match. If I'm over here, what's the square?
Wait, where are you? Right there. 2.
2. Everybody see why? Yeah. There. Kind of sort of like that. Does everybody see? If this is 2, then this is 2. But what if it's just in the middle of nowhere? Tell me. This thing, is that X or Y? It's Y. How long is this side?
X. Or no.
If it's a square, they're all the same. This has to be Y. The fact that it's going in another direction is a coincidence. Because this is actually just poking out into space. X is flat, Y is flat, and then this Y that's poking out is just not on the graph at all. It's just poking toward us. It's sort of like, so you see the paper on your desk here? The x-axis is left, right, the y-axis is up, down, and something just pops out 3D. So if I say here's a square, let's just say it's let's say you have a 1-inch line segment, pop it out and make it a square. It's just, this is not y because it's going in the y direction. It's y because it's the exact same length.
But okay,
Do you see why this is, how come this is y?
yeah.
Because it's going in the y direction.
But why is it equal to what? Like,
Sorry.
why is it a square rather than like a rectangle?
Because they solved it. The test question will tell you.
Oh, this isn't like a law.
Correct, it's not a
Oh,
law,
okay,
correct.
Okay,
Oh, good question.
okay.
By the way, everybody look up here, don't lose this. I could make it a different shape, man, a different shaped shape. Which, does that make any sense? A slice of a different shape. In other words, I didn't have to make them squares. I could have made them triangles. Look up here. Everybody. I could have made this an equilateral triangle. And if you had the 3D shape, you would have like the croissant with one big ridge going down the middle, with all the points of the triangles. Does that kind of make sense? It's hard to picture the 3D shape here, but I could make this anything I want. I could make them semicircles. And then you'd have a nice round croissant that actually looks like a croissant. Does that kind of make sense? So this, the only reason this is Y is because I know this thing is a square, because the test question said so. Can somebody give me the volume of a slice? How do you get what shape is this, again? Deliciously.
Like the square that you drew, or?
Right, and what's the area of a square? Like just in general, how do you find it?
Times it minus the size.
Yeah, multiply the two sides, length times width. In this case, what?
Y times Y.
Y times Y. Now what about a box? This is called a rectangular prism, by the way. I'll just call it a box. A very, very, very thin box. Yeah.
Is it y times dx?
Ah, do you see the thickness of this slice is going to be in the x direction? The volume of this is y times dx. That's the volume of one slice. Did anybody see something wrong with this, by the way? Yeah. Yeah, mismatch. Is there a way to fix that?
Yes.
Yeah, what is y equal to? Let's do that. Radical x times radical x times dx. Can we simplify that? Yeah,
X dx.
it's just x dx, which is very nice. So the volume of a slice is x dx. So a single slice is wherever the x is, that's how long it is. So what's the volume of the entire thing? How do you find that? No.
Do an integral from
Take an integral from what to what?
0 to 4,
Yeah, why not from 0 to 2?
because you want to add up the dx's, so you have to add up them in the x direction.
Right. The dx will tell you what variable to use. If it were dy, I'd be going from 0 to 2. But since it's x's, I'm going from 0 to 4. From 0 to 4 of what? Go.
X dx.
Do it for me. What's the antiderivative?
So 1/2 x squared
Good. From what to what?
0 to 4.
Yeah, pull the 1/2 out to make it a little easier. So 1/2 times what?
16 minus 0.
Right, it's 4 squared minus 0 squared, which is just 16. And what do you get?
8.
You just found your volume. Does that make sense? I could change this shape to anything I want. I could make an equilateral triangle. I could make a 30, 60, 90 triangle. I could make it this could be the base of a regular hexagon, if you want to be insane about it. It works, it's possible. In geometry, they actually showed you how to get the area of a regular hexagon, I assume. Did they?
Don't think so.
They could have.
Like on that day.
On that day. Just for reference, because nobody should leave high school without knowing how to do this. Regular hexagon is a hexagon with all 6 sides the same, and all 6 angles the same.
Is it like 2 triangles plus a square?
And as a matter of fact, that's kind of true. If you divide all the diagonals, look what you made. I pretend that's like hits at a point, because I drew it badly. You got 6 triangles. What kind of triangles? They are all similar, they're even better. They're equilateral, and they're all congruent. They're identical. So basically 6 equilateral triangles. So if you know the area of one equilateral triangle, you can get this thing. Let's just say that this is S for side. The area of an equilateral triangle, you might want to write this down because this might trot out the week after break. We're going to be using, because if I start using slices that are equilateral triangles, this is good to know. This is S squared radical 3 over 4. That's the formula for an equilateral triangle area, given S as the side. Long story how we got that, but they basically found the height of this triangle. They did base times height divided by 2. And this is a 30, 60, 90 triangle. So they did 1, 2, radical 3 and found the height, then found the base, then multiplied them and divided by 2, and ta-da. So to get the area of this thing, multiply it, so regular hexagon is 6 times S squared radical 3 over 4, which reduces to 3 S squared radical 3 over 2. Why would I care? Seriously? If I made this X, then the formula would be 3x squared radical 3 over 2. I would plop that in here. Does that make sense? So if I had a whole bunch of these that were regular hexagons, all you have to do is find the volume of one slice, one hexagonal slice, and then do the integral. You can do any shape you want. As long as geometry can give you the formula for the area, you got it. Calculus will do the rest. Okay? And the calculus here is actually not all that hard. It's just a really generic integral. Make sense? All right, that is the topic that's going to be hitting us after, near the end of the chapter. There are actually 5 topics in this chapter. Volume by, 6. Area between two curves, which we already did. Volume by discs. Volume by shells. Volume by custom slices. And then we'll do things called arc length and surface area. For that, we're done. Please stand. Wow.
Pretty good.
I cannot end this quarter that way. Wow, come on. I was just flipping the wrong one. There. In the name of the Father, and the Son, and of the Holy Spirit. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Well, God bless your trip.